This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seeberg. Good morning, Robert. How are you?
Oh, Peter, I'm already in a full vacation mode.
Oh, really?
Yeah.
I was just thinking, is this the final news we're going to be doing? Because we're going to have three more episodes.
Oh, not three more episodes. I'm full in vacation mode. Because if the kids don't have to get up in the morning, then everything is more relaxed and and it's August, everybody is in holidays. And
I was going to say, this is the week where in Germany, because I think in Germany, holidays start in the north, and they started, 5, 6 weeks ago? Yeah. And actually in the north, this week is the final week they have holidays, right?
Yeah,
and in the south, where you and I are based, holidays started. So this is the only week overlap where everybody is... on holiday, right?
Yeah. But let's get started. In the main part, Georgia is waiting with AI basics in robotics, and I have nothing in the news, but do you have something for the news part?
I have.
Fantastic.
You and I went to see Peter Curtis, CTO of Siemens. When was that, a week ago?
Yeah.
And you kind of maybe surprised him with the first question. You remember what that was?
The first question was, what was your first prompt?
Yeah, and what was your last prompt?
Yeah.
I'm going to ask you that question today. What was your first prompt and what was your last prompt?
My first prompt was, do you know the AI pod? So, a podcast.
Oh, really? What was the answer?
Yes, ChatGPT knows the answer. It's a industrial-focused podcast produced by Robert and by Peter.
Very good.
And my last prompt, that's funny because we were looking for a hotel in France and wrote the town and said, please find a hotel with 3 kids and which is not very big hotel and a good food and near to the ocean. And it was for research to find the best location for holidays. Yeah.
So did you get some good proposals there?
Yeah, absolutely.
Because the last thing normally you would be using, we have been using until today, a search engine, typically Google, all of us.
Yeah.
So what was the different experience then? Did you get it more, more verbose, different?
No, it was focused on my requirements. Yeah.
Okay.
Yeah.
Good. Yeah. My first one I recall was the weather in Munich. That was still GPT-3. How long ago is that? Is that already 5-6 months ago, I think?
Maybe. Yeah.
Which of course it didn't know, because at that time I didn't know that there had been a cutoff date of 2021, something like that. Yeah. That's the first. And the last one, I did produce a chess video. Oh, that's a complete story in itself. Maybe we should do that next time.
Okay, perfect.
But I have this wonderful idea about a chess. Whenever I play chess online, so not over the board, but on screen. And I suggested it to chess.com, but they hadn't reacted. And then I saw somebody that used the plugin, so GPT-4 plugin. And I did produce a video. It was a very basic 1-minute video, but it was showing the base idea. That was the last thing I did. Yeah.
Okay, perfect. So what do you have in the news part?
Yeah, we're gonna have more on the same topic, of course, and we're going to continue to do for quite some time in general and also industrial specifically. The first one that I thought was really interesting is that a judge appears likely to dismiss the AI class action lawsuit by artists. Okay. So we've all seen, this is a general thing, but again, all these topics, you dear listeners that are interested in the industrial AI podcast, the general things that we're discussing here, and we'll come to that later, they do apply to us in the end in industry in its most general form. So writers, musicians, designers, actors, any of us. I mean,
Yes.
you yourself, I believe, are a very creative person. Robert, you have people in your company that are creative people everywhere. Creatives of all sorts, they see their bread and butter work disappear, by generative AI solutions. And some of them want to be reimbursed because of copyright infringement. That's what they believe. I'm not going to take sides here. Several cases have been brought up in front of U.S. judges. I'm not sure if you know of any others. And then last week there was a judge. He's William Orrick. He's U.S. District Court, Northern District, California. He heard arguments on the defendant's side to dismiss the case. It was Anderson versus Stability Limited.
Okay.
Stability is the company. They claim to be the world's leading open source generative AI company.
Yeah.
They're the owner of Stable Diffusion, for example, right?
Yeah.
AI text to image generator. That's what it's all about. In this case, it's image, but it's in all the other directions that we'll discuss today as well. Now, during the hearing, the judge appeared to side with the AI company, so with Stability Limited, thus making it likely this person who was writing the article saying that he would dismiss the case. That's the last time I heard. Quote unquote, he said, "I don't think the claim regarding output images is plausible at the moment because there's no substantial similarity." And what he meant is similarity between images by the artists and images created by the AI. So that's the topic. I'm not sure if you have heard any elsewhere. Have we seen any cases brought forward in Germany, other places?
No.
This is so substantial, the direction we are going to take, we judges are going to take all over the world. If I recall correctly, it was already like a month ago that the Japanese government, that they took the most free approach that you, I believe, can ever imagine. That's what.
Are you sure Japanese?
Yes. I
think it was South Korea.
I'm relatively sure. So maybe we look into it, and if we find an interesting article, then we can still put it in the notes. Now, I think it was the Japanese government that took a very, very free approach. Maybe it was the South Korea. I think it was the Japanese. That's the only thing I'd heard. Now, because what direction if it's the US and maybe in the end the European judges and then the Chinese and all the others are going to go a certain or different directions, it's going to have a very big impact on anybody creative, and that is including you. And we have all these people listening, you that are on one hand technical. Most of you are very, from a business perspective, interested in what we discuss. But we also have the designers. We have the engineers that are very technical, but we have those that are less technical and are more interested in designing a beautiful product. We have Tom from Cadera as an example I'm thinking of now, who comes to us in AI in the Alps, who always make sure that the usability. So all these people that are somehow related on creative work, they're going to see one way or the other. They're going to continue because then they're going to be paid by the AI companies. Maybe that could be a solution. We don't know. But, what this just says, no, he doesn't see the similarity between. So he doesn't at least see a copyright infringement, not based on today's law, right?
But we have a lot of discussions with Tom, especially from Cadera Design. But he sees the future for his company in explaining the workers next to the machine how the model performed. So it's not the design process anymore, or to make something beautiful or something. It's more to make AI explainable, and that's the future for him, he thinks. Yeah,
that's a wonderful idea. And we're going to close off maybe today with a piece from Mercedes-Benz, who's already using ChatGPT in production. That is very close. So, as a nice example, then Tom is taking this very freely, openly. One way or the other. I think it doesn't matter what way this is going to go. Yep. It's for all of us very important that we keep a very open stance towards what is happening, and we need to be all very open and agile and try ChatGPT and Code Interpreter, see what it can do for us, and see how each of us, at whatever kind of position we are, can do with it.
Absolutely.
So I wasn't sure that we already discussed it because I had Code Interpreter here. You remind me because we
had an episode on Code Interpreter, yeah.
But we didn't move our news part one week before, right? So not sure. Then I'm not going to go in too much details. Then we did Code Interpreter. Well, having said that, you can't. I really believe you can't discuss enough Code Interpreter these days. I really believe so. If there's only 1,000 people now of you listening who haven't heard it before, then you must involve yourself with this. What I did then, and it was very similar to what Marco did in exactly, I think it was the weekend, Professor Huber, Marco, the weekend they were in the Alps. Was it that it doesn't matter what weekend he was doing what? That's GPDR, we're not supposed to know. But he was playing around, and I think I was playing around almost like the same weekend or a week later, right? And I was, so impressed, right? Because I took this data set from Kaggle, there's a gas turbine, and it's already suggesting. Now, I do want to share with you now just 2 or 3 that I think is so structurally different what Code Interpreter is doing. I'm not a data scientist. I have been involved, but at that time there were, our data scientist colleagues doing the actual work. And I'm actually going to ask, because I did, at that time it was Adelina Horvath, who is now machine learning engineer at Cognizant Soft Vision, or Albert Krohn. We had Albert with us.
Yeah, it's AutoML, right?
Not specifically. I believe he's doing rethinking self-service analytics. Yes, not on the terminology, I believe, but a similar direction. So I'm still going to ask both of you, what do you think? Because you, together with us as a small team, were producing at that time the algorithms. What do you think of what this is all about? Now, what I like best about this Code Interpreter, and I'm talking data, the data science part. I'm not talking writing code. For those of you that are more into the writing code business, but I think that's a similar approach, but I'm talking here about data analytics. So what I really, really like best, it takes me by the hand. It recognizes what I gave it, and it gives me suggestions what to do with it. So here's a quote unquote. You take a file, you have to do it with this GPT-4, and then you go to the Code Interpreter, and then it says, great. You've uploaded a file named GT full SEV. How would you like me to assist you with this file? Would you like me to load it and provide a summary of its content, perform some analysis or something else? And I think, Oh, yes, please.
Yes.
So that's what it does.
Yeah.
That's what it does. The CSV file contains, okay, these are the columns. I'm not going to go through it. It's too long. Now, this gives you a sense of the range and average values from each of the parameters. What would you like to do next? And then I say, add something with CO2 and NO2. Okay, let's approach this in 2 steps. And it says I can do a correlation analysis. I can do regression analysis. What do you want? I say, okay, let's do the correlation analysis. I'm fine with that. And that's what it does. And then I ask it, can you first show me the correlations in the plot? It shows me, in a very nice graphical approach. And it continues like this, like 15, 20 minutes. And my feeling is that I have the results that, and again, Adelina as an example, but all you data scientists listening as well, let us know. Let us know what you think of this tool. Does it really do the base work? Does it do the base work that maybe you until now have been doing and spending, I don't know, I can imagine a couple of hours or morning or a day's work until you arrived at a certain point where now this tool takes me, and that is a very important thing to come back today again, takes me, the not data scientist, but a person interested in data. I was a program manager, running these projects for the domain expert. The domain expert, and that's what we'll finish with today, in the production line can now do this as well. What do you think?
I found Marco's idea very exciting, because to extend the Code Interpreter to an AutoML tool. You heard the episode with Marco, I think?
Yeah,
and
sure.
He said maybe it's the first step to get an AutoML tool, or to combine both words, the interpreter and an AutoML tool. I think that's That's really interesting. And I will discuss this with Frank Hutter in September, because Frank has this big conference, an AutoML conference in Berlin or in Potsdam. And maybe I will bring this topic on the agenda, because I think it's could be very interesting for this whole community, right?
Maybe. I'm thinking with your information, and I put another step on top of it, because then I think, well, I'm not going to put this question. That's not fair to Frank, but I was thinking of, do we then need AutoML? My point is, what you just heard me say, that was not me. That was the algorithm. The algorithm, no, the algorithm is already at a step higher. Do you understand my point? The point is, I only give it a file, and it does the analysis, and it speaks to me. Yeah. And then the next thing is of course, what I now hear is Sepp Hochreiter. When you and I started, was it 4 or 5 years ago? Yeah. And Sepp famous quote, "Don't screw it up." Yeah, and then there was the example of the interaction with the machine. What was the interaction?
It was oil, hydraulic oil or something.
Yeah, so it's like, so I speak to the machine, "Are you okay?" And the machine says, "Yeah, I'm fine." But maybe, back in the end, number 2, 3, I can do with a little bit more oil. That was SAP 4 or 5 years ago, and that's what I see now happening. It's really. Absolutely. And the point is that this is the algorithm, so it doesn't need to explain to me AutoML. The point is already a step further.
You can discuss this with Frank, I think.
Yeah.
He has a different opinion on this, I hope.
But that's okay. Okay. All of us. And that's what I have been saying since, I may have given this example before. It must have been 30 years ago at Intel, 2 in a box. And at that time it was literature. We had I think there was like 25 people in literature, and the job was to put it onto the internet. So from that point on, I know since these 30 years that all of us, always, including myself first, that jobs are changing. And for nobody, not for you, Robert, not for me, for nobody can say, "Oh, I'm going to just continue doing." Okay, when you're 1 year ahead of your pension and you don't want to get into it, that can be your personal call. You can still be interested.
Absolutely. So I would like we make a stop on this point, Peter, because I would like to remind all listeners about the survey of Zurich and the Technical University of Zurich. We already mentioned this survey in the last episode. You can find it in the show notes, because it's very, very important to take part. We make a own discussion about the survey in autumn this year. So please participate in this survey. Yeah, it's very important to get a status quo on industrial AI in enterprises. Yeah.
Good. You put the link into the show notes.
I will put the link in the show notes.
Yeah, I have a final one.
Yeah.
It's just another use case. I just mentioned it. It's the ChatGPT in production. It's amazing. And it's not just some company, it's Mercedes, the company that we in Germany are still, not everybody, maybe, then I get into a political discussion if you're still allowed to drive a car or not. But nevertheless, let's say, sure, it's a huge, very important brand. I think, didn't they invent the car or the motor at least? So they use ChatGPT in vehicle production. It is now supporting production employees as a universal voice-based interface, what we just talked about. Yeah. And I think that is so amazing, right? That's what we've been talking about. So instead of what they say, complex programming functions, so here we go back to the idea of the code interpreter, the queries are steered in a dialogue. Just what I just did with the data science. Now, not only engineers, but also employees without prior programming knowledge can have the necessary data at their disposal. Yeah, that's AI democratization, full stop. And as you just suggested, I believe that is in the end our overhead topic for the November AI in the forest, right?
Yeah, but I recorded an episode on this topic with Fruitcore Robotics a week ago. Okay. It's a German company near the Lake of Constance, and they use large language models in their robotics applications to handle cameras and to optimize coding. And that was very interesting, how fast they implemented this new user interface to the customer. It's very, very interesting. A very interesting episode, yeah.
That's maybe as a close, and that's what I really do believe, that the forward-looking capability of ZEP 4 or 5 years ago, that is taking place right now. What is interesting is that at that time we were thinking of the voice assistants, personal assistants, which we still have. I don't have it in the room. I'm here. The Alexa, the Siri, etc. And that seems maybe, well, in combination or not, but with the capabilities of ChatGPT, Code Interpreter, all of these, that we are now getting our real personal assistants that can do more than, play the Beatles or tell me what time it is. I can now stand in front of that machine and really, find out what's wrong with you, or where are we, in whatever responsibility I have in a production line also, I don't have to be the production line manager. Whatever is my job, in the production line, I can speak to my environment and learn what it's finding out.
And I want to come back to the robotics, because Fruitcore is a good keyword, because in the main part now, we also talk about robotics, and you can learn something, Peter, because you're not in the robotics business. So you have to hear this episode with Georgia from Technical University of Darmstadt and Sheila from Women in AI and Robotics. 30 minutes. Basic AI and robotics. Very, very interesting. Yeah.
I listened to all of our episodes.
But there you can learn something. Yeah.
But I learned from all of them also.
Perfect. Yeah.
So just for our listeners, then is this the final time that they will hear us before the holiday break? Because next week we're going to have Peter Curtis, CTO from Siemens.
Yep.
And then you did an episode with Porsche, right?
With Porsche, yeah. At the end, there's Porsche. Very, very interesting episode with Porsche.
And are you and I going to do a news update in between? Or, okay, so that means then, dear listeners, we're going to be out of the air for 3 weeks, right? And we're going to be back as Robert and Peter and see with whom we're going to do a recording.
With Oliver Niggemann, you
with
mentioned.
Oliver, that was the idea, yeah. So Oliver, if you're listening, be prepared. And that's going to be then in the middle of September, right?
Yes, exactly. Peter, enjoy your holidays. It was a pleasure. Thank you very much.
Thank you, Robert. Thank you, dear listeners. Have a wonderful holiday as well, wherever you are, and talk to you. I hope that you are going to listen to us again back in September. And in the meantime, listen to the different recordings we've done. Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you, Robert. It is exciting to do our second episode together. And today we have Georgia with us. She is from the University of Darmstadt, and I would like to pass on the mic to her to introduce herself and tell us a little bit about her journey.
And we talk about AI and robotics, right? That's our topic today.
Yes, definitely.
Perfect. Georgia.
Thank you very much for the invitation. I am Georgia Chalvatzaki. I am originally coming from Greece. I grew up in an island in Greece. I come from Rhodes. My dream was, from a little kid, I had many interests, but early on I had a big excitement about robotics. Initially, I considered it to be a toy or some science fiction, but then as I grew older and from different inspirations that came out during my school years, then it became very clear to me around 15, 16 years old that I want to do robotics. And in particular, I was interested in programming robots. So I was interested in giving robots behaviors so that they can be useful in different domains. Long story short, I ended up at the School of Electrical Engineering and Computer Science at the National Technical University of Athens in Greece. I did all my studies there, so all my undergrad and then later on my PhD. The topic was learning methods for assisting robotics, and in particular I was working with mobile robots that would assist and the elderly people with mobility issues. And I investigated ideas from classical robotics and human behavior understanding till control. And then during the last years of my PhD, I started looking more into machine learning methods for robot learning, basically. By the end of my PhD in 2019, I wanted to continue on, so I really wanted to stay in academia and have the flexibility to research many open research problems that are pertaining robotics. Yeah, so I wanted to focus more on AI for robotics. So I researched which are the labs where I could do a postdoc in this domain, and I found out that at the TU Darmstadt there is a very nice, let's say, hub of AI researchers, and I applied for a postdoc at the lab of Jan Peters here, and then in the end of 2019, I transitioned to Germany and TU Darmstadt right before the beginning of the pandemic, and the first basically period of the postdoc and the pandemic, I spent it writing a research proposal for the DFG, the German Research Foundation. This funding proposal that I applied for is called the Emmy Noether Programme, which is a very competitive research program that only, let's say, top researchers can achieve. I was lucky enough and I worked a lot for it. I received it, and we arrived at 2021, where I started my research group here at TU Darmstadt. With this research group, junior professorship came along, and after that, several offers also appeared from German universities. And after April 2023, I became a food professor here at TU Darmstadt.
Wow.
Fantastic. What a journey. I think I'm inspired by your journey, Georgia, given that I think you have accomplished a lot and at a young age, and congratulations on that. So getting a little bit more into what you're doing at the Robotics Perception and Learning Lab. So inspired by the embodiment hypothesis, which suggests that intelligent behavior may be acquired by the continual purposeful interaction of an agent with an environment and the induced sensory motor experience, you are developing methods at the intersection of robotics and machine learning for mobile manipulation by enhancing model-based methods with the adaptation properties acquired by exploration and learning. Can you dig a little bit deeper into this for us, please, Georgia, and share with us what are these model-based methods that you're working on, and what is the story?
Yeah, thank you very much for this nice introduction of our research area. So as starting basically with my training as a classical, let's say, roboticist and engineer, I focused a lot on methods, for example, that involve planning, that assume that you know basically the dynamics of the robot, that you assume that you know the dynamics of the world and how things work, which is not the case in the real world. And this is where machine learning can basically close the loop. So in particular, what we are trying to investigate is what are the conditions and what are these, as we call them, representations of the real world that would allow us to apply this model-based classical methods of planning and control, which enjoy guarantees of stability, convergence. So when you deploy these kind of solutions that are concrete mathematically, you know that you're going to find a complete answer, which has basically mathematical proof. This is not the case when you are dealing with machine learning algorithms. When you, for example, train a neural network, you don't have exactly guarantees about the output of this network. So we are looking into how we can constrain, for example, these neural networks, or how we can combine them with these more classical approaches so that we can make the classical approaches more powerful. And on the other hand, make, for example, the need for data less demanding. So if you combine a classical method, so you assume some things already that hold about, for example, just Newtonian motion, which is, let's say, very well understood and known. And on top of that, you build something more that it is learnable, that it is this missing component that your equation is not directly explaining. Then you can basically go beyond our classical formulations. and therefore you can scale up. And on the other hand, your machine learning algorithm will not need data to learn anything, even the more simple thing. So if you give already some sort of information, or as we call it, inductive bias, which is some sort of prior information about, for example, the structure of the system, some knowledge that you have, then you can accelerate also the learning of the machine learning algorithm, which I think it's both an interplay that it is very favorable.
I have one question, Georgia, because you mentioned classical methods and machine learning methods. How difficult is it to combine both worlds?
It is challenging because they refer seemingly to different things. So the classical methods have an issue when it comes to scalability. When you consider, for example, an observation space, that it is very hardly interpretable. So consider raw images, laser scans, and force measurements by a robot. You cannot just plug in this thing into an equation and expect it to work. You need to extract some sort of representation, some, let's say, feature space that can be less complicated, hopefully, than the one that you had initially, let's say, from the raw sensory inputs, where it would allow you to apply there, let's say, some search-based approach, for example. So yes, they can be combined, but it is not really clear how. So this is an open research question. So we have different approaches on how to go about it, but it's not like we have a clear solution right now.
Right. So what are the challenges of deploying the machine learning models on the robots?
The most important one is safety and robustness. So you cannot really control a neural network. Like if you train a neural network and you just take the prediction, when I mean raw, I mean without manipulating the prediction to do some sort of check or have some safeguarding to understand whether or not this action would break the robot or not. If you want like to control a robot from a machine learning controller, then there is big risk when it comes to this deployment, because maybe this controller has a lot of noise and it could exceed, for example, the limits of the motors of the robot. It is very easy for these methods to overshoot. So you still need, there is no such thing as direct deployment of a learned controller on the robot. Still, there is always on the low level an additional controller, trajectory tracking, a PD controller, that will try to filter out a bit. But it's not always possible. So this is why currently learning methods are easier to be deployed on a higher level of abstraction, as we say, not directly applicable to the robot joints, for example, but a bit higher, like a goal that the robot has to reach, a sub-goal, let's say, like the next location that the end effector of the robot should end up. And then you deploy a classical solver to move the robot, to find the path that will bring the robot from the current location. So then you deploy a classical solver to find the path that will lead the robot from the one position to the next. And then again, you have the classical low-level controller.
Mm-hmm. And how do you measure the accuracy of these models, and what is the criteria for, success?
Yeah, this is a big issue in robotics in general, that we don't have standardized benchmarks. So there are some things that are like some common sense when it comes to testing your robot. So you test, for example, a success rate. So suppose you have some sort of task that has to be achieved at some specific time horizon, and then you just measure success rate. So you do an experiment over and over again. So you basically, all our evaluation is kind of empirical. You have to test it on the real system. Other things that we would test is how smooth are the motions. So we are going to check the accelerations, for example, that are being induced, the total path, energy consumption. These are, let's say, metrics that are a common knowledge in robotics, but there is no such thing as a universal benchmark, and this is quite an issue. And if you think about it, it kind of also makes sense, because there is no universal robot. every hardware has its own specifications, its own issues. An algorithm that may be developed to work on, let's say, low-level control of a robot, even if it is learning-based or classical one, may work perfectly well on one type of robot, and then maybe you transfer it to another brand and it doesn't work anymore because it's different noise of the motors, noise of the sensors, and so on.
I want to come back to this. You mentioned this safety topic, right? Because this is a huge topic in robotics and when you talk about the industrial sector. And is it possible to build a model that anticipates possible safety problems before the robot stops based on AI, you know? Because when the robot stops and the line stops, then we have a big problem because it costs a lot to restart the production. Is it possible to find a AI-based safety prediction or something?
Yeah, definitely. There is research in the direction of, let's say, anticipating the future or anticipating failures, for example. Which means that you need the data or to have sort of specifications. So there are, again, two directions in this case. The one case is the data-driven one, so the one that wants to experience failures or some sort of distribution of failures and therefore be able to classify a possible prediction of the future. Like, if I take this action, what will happen in the future? Will it be successful or not, given the current condition? And therefore, you can do some sort of probabilistic, let's say, modeling in this case. These can fail in the case that your distribution is very narrow. So if what you have experienced so far is not, very broad, it's quite easy to not really predict events, a new event, let's say. So the generalization is still an issue. The other approach is to have some sort of formal specifications. So instead of trying to predict, let's say, success and failure, you can predict your next action and then use some formal specifications, which is, again, a classical method in the formal methods, basically, in order to understand whether or not this action is going, to break something logically. If this breaks something, then you basically abort or you filter it out and you don't take this action. But necessarily you should give a feedback to the system so that the system can self-improve or reject this sort of action given a certain condition. And again, the problem that you have when you want to define formal specification is that you may want a human being able to literally write all these specifications and then have some sort of mapping from action of the robot to this formal language, which is a discrete language that will be able to check, is this true or is it false? Should I continue or should I not continue? I believe that a combination, again, of both, so a machine learning method together with some formal specifications that can have some sort of guarantees is, again, a research problem, but it is, let's say, a favorable solution. And in the case of the industry, for example, in certain settings, it could be easy to specify basically and then certify a solution because it is a semi-structured environment. So you can anticipate certain events, right? So if it is, for example, a domain in which water can never exist because it is, inside an area that you are not allowed to carry water or whatever, then you don't need to account for the case if water appears. Stuff like this, for example, we could define in the industrial setting. But if we are operating in the open world, like if we see into agriculture, for example, 4.0, then it is a very unstructured environment, right? You cannot anticipate many things.
Mm-hmm.
Yeah, and so I was just curious to learn if the research that you're working on, are you using cloud and edge solutions a combination of both? Or, what is the best method to improve the performance of robots? I hear a lot about the promises of edge solutions and how it can be incorporated in combination with the cloud. So is that applicable to what you're working on?
So for us currently, it's not easy to use cloud-based solutions. In the past, there were some things that you may, for example, share in the cloud in terms of, for example, knowledge bases, in particular in large-scale projects with different European universities and companies. There you have to share, let's say, knowledge. Therefore, you would transfer things into the cloud, but then again, querying and adapting to different robots and different situations is not always easy when you don't know exactly which machine learning model you want to use. So there are no straightforward solutions. What is really interesting and possible is to, let's say, have an army of robots in your warehouse, for example. That would be a single type, like all the specifications, you have a single type of robot, and therefore you can share experiences. One issue, but I think this is possible to be tackled with good engineering, is latency. We need to ensure that if we deploy cloud, the queries are going to be in very, very, very high frequency, kilohertz or even more, so that we can ensure that the performance of the robots will not be deteriorated. But right now, I don't think there is the infrastructure yet, unless a company wants to invest in it. University-wide, this does not exist.
So what would be the advantage of having cloud anyways?
The advantage will be the sharing of experience. So collecting basically different instances, and therefore, for example, failures that we were discussing before. Maybe a robot fails in a specific task and another robot fails in another task, and therefore you could share these experiences, and this could lead potentially to some sort of generalization. So maybe there is a task in between these two failures that you can predict a failure even if you haven't experienced it. So definitely having collective, let's say, data, it's interesting. But again, understanding how to clean and use this data is very, very important. So to give you an example, DeepMind, Google DeepMind now, that it is a leading research institute, of course, in industrial, it's part of Google now, that they actually crowdsourced data demonstrations. Actually, they spend a lot of time and money into cleaning the data. It's not like we collected the data and then we throw it into some network and then the network suddenly does magic. And the same happened also with the large language models. OpenAI has spent quite some money to basically get people to be able to label the data, to clean the data and to label them as good and bad.
You mentioned this data topic because I was at the Automatica, and one big trend is at all booth there was using scientific data from CAD models, from the digital twin, and then to use or to train a model. What is your opinion on this?
I think that using simulators is necessary in robotics. How good and how close to reality the simulators are, it's a big issue. So this is why there is no one common solution across everybody. But it is also a way of not wasting money by breaking your robot into the real world. So robots currently are very slow. So even if you wanted to use them to collect data, let's say that you had a safe setup, the time that you would need to collect the data, it would be exhaustive. Therefore, simulators can really speed up the process. So even if they don't give you the perfect real-world representation, this exact digital twin in terms of every possible component, it can really give you data to speed up some algorithm and then combine it with real-world data. Again, this is not straightforward. It still has issues to be tackled there, but there are ways to then boost basically the real world learning by simulated data. I am not really sure if by not deploying learning, just by having something on the digital twin, you can really predict what will happen in the real world. Like if the solution that is being proposed is that I have a table with a robot and some objects, and I just run a behavior on the simulator, and I just expect that whatever is in the simulator will seamlessly transfer in the real world, this most of the times doesn't happen. Then you should tweak the simulator to come closer to the reality. But then the simulator usually becomes super expensive to be deployed for generating data. So I guess the closer it is to reality, the better you can evaluate, let's say, a solution. But the closer it is to reality, the harder it is to use it for learning.
And in which application do you see AI in robots in the future or tomorrow? Because in my opinion, now it's a lot about vision and vision technology. Now we go into something like construction or optimizing the planning. Where do you see maybe the topic AI safety? Where do you see use cases for AI in the future?
I guess in robotics, right?
Yeah.
We want to focus not general AI. Yeah. No, I think that the applications are actually many, especially because we lack right now also people working in several domains. When we look into the logistics sector, when we look at warehouses, when we look, as you said, like in construction side, we don't have any more laymen, right? Like in a few years, that will be the people now have more skills, right? Now it's easy if you want, you can sit in your house and you can learn code. Why should you go to work on the construction site on jobs that are also ergonomically very, very bad? So you would need humans to be more on a high level teleoperation, let's say, mode, or just being inspectors of robots doing things for you. So yeah, as I was saying, like logistics, inspection, hospitals, nursing, supermarkets, airports. I believe that it is very, very important that in the next, let's say, 5 to 10 years, we will have robots operating on these sectors, because it will become problematic on who is going to work on these domains. And I believe that the investment, the one issue behind why we are not there yet is one part comes to the perception. So we were not as good in having good perception algorithms, but now with deep learning, we are doing good steps into extracting these sort of feature spaces and representations, but then connecting it to manipulation. Manipulation is very, very difficult. And having robust and safe manipulation of the world, it's very, very difficult. And currently, I would say the most successful robotic application is drones, because in the air, there is not so much clutter as there is in the real world, or there are no humans. So there is no way that you will pass by a human and you may hurt them. And I think that if not only, from university, but also from the industry, people would invest more in robotics and in these kind of problems, that they also need a combination of research and engineering solutions, and they would really invest into that, then the outcomes, the impact that you will have, also in a matter of productivity and in a matter of income in the end, it will be much, much higher. And on the other hand, this would may lead to a shift also to the educational system, because then you will need people that have different skills than you have right now. So I think that there should be a serious shift, in particular in Germany. Germany should really make a big step now for AI safe, let's say AI.
Trustworthy.
Yeah, trustworthy. Yeah.
Sheila?
Yeah, I was just going to say that talking about large language models and generative AI, I was just curious to see what role do you foresee this playing in the future of robotics?
I am looking into the progress. We are also using them or trying to understand them.
Yeah, because a lot of people are using now LLMs to optimize usability or human-machine interfaces. Yeah, I want to add that. Yeah.
So I see these language models as, let's say, models, functions that are able to compress a lot of knowledge, a lot of information. The way that you can take out this information is not very clear. It's not very clean. It's not easy to understand if these models have learned also some sort of reasoning abilities. There are sometimes some words that try to basically show that there is this kind of reasoning, but then when you give some sort of adversarial example, these methods totally fail. I don't think the humans, for example, are generative, and I don't think that the solution to AI is generative models, but I can see them as a very good initialization of other algorithms. Basically, you can extract possible, for example, solutions and use outside information and constraints that have to do, as we said, with specifications, with safety, and try to select the most possible solution. So I don't believe that a single model will be able to, on its own, let's say, solve reasoning, let's say, abilities of robots. And especially they cannot be 100% connected to the low-level robot execution. So they will not solve the problem of the motor having noise. Also, if you look at the humans, how the human starts, the human doesn't start by language. The human starts by emotion and by perceiving. And after achieving a certain level, right, because in this case, you build representations and so on, there are certain skills that you acquire by language. So I think that we need to make sure that we understand also where we use what. But I can also see now these language models being a very good interface, as we were saying. So in the past, we were also using language to interact with humans and also in interfaces, and we would use language templates, which would be a bit rigid. Maybe sometimes you would put inside the template maybe a word that didn't sound so natural to exist, let's say, in a sentence. So these language models definitely are going to give this more human-like responses that would have the potential to make a robot more likable and trustworthy. I am not sure. Trustworthy, I'm not sure, because we know that language models make up things and they have this way of conducting sentences that they sound as if what they say are facts, while we know that inside there are a lot of fake information. So we have to, in my opinion, we have to be very, very careful. And I think it is a revolution. And as with every revolution, we have to learn, exactly as what happened with the internet, basically, the World Wide Web.
So being a technical person working on robots and AI, machine learning algorithms and so on, how do you, the robots that you're working on in the lab is assistive robots for the healthcare industry. So I'm just curious to know, how does this, the feedback from the patients or the people in the homes who may need these assistive robots and whatnot, do you work with people from the healthcare industry or, for example, social workers, people with direct contact with those who are in need of these robots to better understand the usage of this? And, can you help us a little bit understand the feedback loop from the user of these robots and how that gets incorporated into your solutions?
So especially when we are looking at these domains where you have very close interaction with humans, usually how we start is that we bring the experts. So as we said, for example, we talk with healthcare workers, or if it goes, for example, to manufacturing, we will talk to people working in this specific domain to really understand what are the needs, what are the user specifications, what are the needs. We may even collect data from the people to understand behaviors, to model their behavior so that we can have this sort of anticipation, right? Especially if you consider a human and a robot interacting and collaborating in something. You really need to be able to foresee what the human wants to do because we as humans have this sort of mental models and we want our robots to have the same functionality. So definitely, and this is something that we have been working on, and during my PhD when I was working more with elderly people and then later on also with other projects. Right now, for example, we are collaborating in terms of logistics with supermarkets and Fraport here in the airport of Frankfurt for a project that will start now. And the first thing that we will do in this project that will start this autumn will be to sit down with the people that they work in these domains and also from different countries. This is also very, very interesting to see how also the work habits and needs might change from country to country and try to collect this information to build our algorithms on top of that. And beyond that, one last very important thing is that even if you endow a robot with very good behaviors, whether they are learnable or a combination of methods, you need to have some sort of personalization. So you would need to adapt the robot online when, for example, it becomes part of our everyday living.
So this is very interesting. So it is possible to customize and adapt the robot to the geographical and ethnical or traditional needs of a country, or that's great. Yeah.
And my last question, Georgia, is when you look at the robotics landscape, what do you think we should look at and why?
Okay, this is a very, very good question because the robotics landscape is extremely broad, right? And
what fascinated you the last 2-3 months? When you say, oh, we should talk about this in the future?
Yeah, what I am definitely interested, it comes basically to safety and robustness, whether it comes from merging perception with some algorithmic solution that may be, planning or learning based, or when it comes to deploying large language models in robotics, because, for certain reasons, certain companies right now are trying to push in this direction that, large language models are going to, robotics is solved. But this is not the case. And I think it's also not safe to even demonstrate something like this or like try to tell the people that, everything is solved. So we need to look better into the issues of robustness and safety because, for example, these models that don't know anything about uncertainty. They don't know, for example, anything about the fact that if my robot goes to grasp something, there is some probability that this thing may slip out of the hand. And while the robot thinks that it has the object in the hand, the object is not there because there is no such connection between, the reasoning part and what happens actually in the physical world. So looking into these problems of safety and robustness, and then if we look at one step further, the problem of trustworthiness of AI solutions as they get integrated into work and society, I think it's the most important step. And as I said, I believe that Europe has to play the most significant role there.
Georgia, it was a pleasure to talk to you. Thank you very much for your insights. And Sheila, thank you.
Thank you, Robert, and thank you, Georgia.
Thank you both.
It was a pleasure.